I want to show how to solve linear inequalities that include absolute value. And I think an important thing for us to remember is what we mean by absolute value. So for example, if I said I want an absolute value that's less than 6, well, if you think on a number line, that would mean that this number has to be less than 6 units away from 0. So obviously if I go 6 in the positive direction, anything less than that will have absolute value less than 6. And also if I go in the negative 6 direction, anything greater than that will have absolute value less than 6. So to drop the absolute value of these inequalities, then what I'm thinking is I need to find all the values in between negative 6 and 6 for this example. Okay, so the same applies when we have situations like this. When I have 2 times the absolute value of z plus 5 is less than 12. And what you want to do is you want to isolate your absolute value. So first I'm going to divide both sides by 2. So I end up with z plus 5 in absolute value is less than 12 over 2, which is 6. And so now I'm thinking that I need to figure out all the z's such that if I add 5, their distance from 0, these z plus 5's distance from 0 is less than 6. And so just like we mentioned, that means I can drop the absolute value and consider when it's between negative 6 and 6. So I get this compound inequality. From there, it's pretty straightforward. I'm going to get z by itself in the middle. So I'm going to subtract 5 from everything. So when I have negative 6 minus 5, that gives me negative 11. And when I have 6 minus 5, that gives me a positive 1. So I end up here with z being greater than negative 11 and less than 1. Okay, now we want these answers in a number line. So if I draw a number line here, I see that 11 and 1, neither one are included. And again, z is greater than negative 11, but at the same time less than 1. So I'm talking about all this area here. So as an interval, that means I go from negative 11 to 1, and I get parentheses on both because they're not included. Okay, so let me show you some variants on this idea. If we look at B part here, I see that I have this time the absolute value of y minus 2 has to be greater than equal to 5. So if you think back to our example here, when we had absolute value of x is less than 6, if I said greater than 6, all of a sudden I'm talking about everything further away than 6 units away from 0. So I'm talking about all these tails, what we call the tails on the outside of the number line. So now when I go back to this part B, I have y minus 2 in absolute values greater than or equal to 5. I need to consider y minus 2 is greater than or equal to 5, or y minus 2 is less than or equal to negative 5. And see, this will push me out in the two different directions along the number line. Okay, so for the first one, I'm going to add 2 to both sides to get y is greater than or equal to 7. And for the second one, I add 2 to both sides to get y is less than or equal to negative 5 plus 2, which is negative 3. Okay, and if you look at the number line here, I have negative 3 and 7, and both of these are included. And the first one says greater than or equal to 7, so I'm going out this way. And the other one says less than or equal to negative 3, so I'm going back that way. Okay, so to talk about these two things at the same time, the first one, I'm going from negative infinity to negative 3, and the negative 3 is included. And how do you know that? Because it's less than or equal to. The previous one was just less than, so it wasn't included. All right, now on the 7, we have 7 included all the way up to positive infinity. And the way I'm talking about both of these is I put in this union symbol. And the union symbol means that I'm combining both of these intervals to create one set. Okay, so there's my solution. All right, let me show you one more. So this one looks a little bit more difficult, but it's not really. Okay, so here I'm going to subtract the 11, so I end up with a negative absolute value x minus 4 plus 1 is greater than or equal to, let's see, 12 minus 11 is 1. And it looks like we're going to have that same situation we did last time with the split number line, but I need to get the absolute value by itself, so I multiply both sides by a negative, and when you multiply or divide by a negative, that means you flip your inequality. So I get the absolute value is less than or equal to -1. Okay, now from there, this is going to be a problem because I know that absolute value always is greater than or equal to 0, right? I mean, absolute value can never be negative. So how can this thing be negative units away from 0? Just doesn't make sense. So from there, I know without solving anything that this one has no solutions. There is nothing that will make it work. Okay, now if you tried it algebraically and got answers, what you could do is plug these back in, and you should plug in your solutions all the time back into this to see if it works, and you'll see that it will not become a correct statement. Alright, so just pay attention to that. Make sure your absolute value is always positive, and I hope these examples make sense. They kind of show the 3 different situations you encounter with absolute value linear inequalities. And please let me know if you have questions. I hope this helps and makes sense, and thank you for watching.